Hi, before we start the ownership concept of Rust, I'd like to explain two different data structures which are used in memory management in Rust. The first one is heap and the other one is stack. I guess you might be familiar with these data structures, but if you're not, it's totally fine. I'll explain these data structures briefly and let's get started. So the first data structure which we should be aware about is a stack. Now in Rust, what exactly happens is for those data types which have fixed size or, or the size of which data types are quite known at compile time are stored inside stack. Let me explain what a stack is. Say you have a number of plates with yourself. If you want to place those plates with the minimum amount of space which they can take, you'll place those plates one upon another, and it is a stack of plates. If I give you a diagram based example, say suppose you have a bucket and you start placing those plates one above another, eventually they'll form a stack. And in the same way, data types with fixed size are stored in stack. Say for example, we have a variable x whose value is 6 and a variable y whose value is 7, and together they make a variable z with an arithmetic operation of addition. And now if we want to understand how exactly these variables are placed, they will be eventually placed inside a stack because integer values have fixed size in Rust and they are eventually moved to stack memory. So here, since we have defined x initially, or the first variable to be defined is x, we'll place x at the bottom of the stack. Then we'll have y, and eventually we'll have z, which is the summation of x and y. Now the operation which is used in order to put x inside the stack is called a push. So we basically push x inside the stack. Similarly, another push will be required to get y inside the memory, and the last push will be for z. Now if I want to get any of the values from the stack, what I need to do is I need to pop the values. Now since this is a stack, I cannot directly fetch x. First I'll have to get z, then y, and then x. Let me show you with an example. Say suppose we have 1, 2 and 3 in the stack, and I want to get the third element or 3 from the stack. I'll have to pop 1, then my stack becomes something like this. I'll have to pop 2, and then my stack becomes something like this, and then for the last pop we'll have 3 out and the stack will be totally empty. This is basically popping of elements, and this is called LIFO by nature, which is called last in first out. Now let me give you the properties of stack. The first one is stack is a bit fast as compared to heap, but what we are doing here is we just have to pop the topmost element and we cannot perform searches here. So it is a bit faster than heap in comparison to what we use in Rust. The second property is only data types like integers, booleans, and arrays of fixed size are stored in stacks. Other than this, if the data is growable by nature, then we move to heap. Now keep these points in mind. We'll move towards heap. If I briefly talk about heap and I try to explain it to you in layman's term, say suppose you have a tree and you're putting in values in order to store those data types or those variable values inside the tree. Now you might have come across a figure like this. This is a visual representation of a heap. This is basically a binary tree which can store values, and heap is basically this form of data structure itself. Like, it is better to explain heap this way. It could also be shown in terms of array, but a binary tree is a better visualization of a heap. Now these values are called nodes actually, and the first and the foremost node is called the root node, and the last node, which does not have any child elements, like this particular node is a child element of the root node. This particular node is like these particular nodes are the child elements of these two. Now those nodes which do not have any childs are called leaf nodes. Now since we know the data structure now, or we know the visual representation of heap now, I'll try to explain how two different types of heaps. One is a max heap and the other one is a min heap. I'll not get into a detailed explanation, but just for information purpose, I'll tell you, say suppose you have some numbers with yourself and you want to make a max heap. A max heap will always have the maximum number at the root node. Say suppose we have like 1 2 3 4 5 6 and 7. Now for a max heap, the largest number will be the root node, which is 7. Now other numbers will follow a similar strategy, which is the base node will never be greater, or it will never be lesser than the leaf nodes. Like if we have 7 here, these two values cannot be greater than 7. It could be 5 and 6, but not greater than 7. Similarly, these two values cannot be greater than 5. It could be 1, 2, and these two values could not be greater than 6 as well. So this could be a possible max heap. There could be more iterations if we heapify this. Now if we introduce 8 here, say suppose we want to add 8 into this particular max heap, the whole tree will change and 7 will find its new position, so will other nodes as well, and 8 will be the base node or the root node of this heap. And this whole process of changing the order or changing the location of each and every node or most of the nodes is called heapification or heapify. Similarly, if I explain you min heap in a very short amount of time, and we have like the same set of numbers 1 2 3 4 5 6 7, the min heap will always have the minimum number at the top, and so on and so forth. The remaining nodes or the upcoming nodes will follow the same structure. Like these two nodes will always be greater than 1. It could be 2 and 3. These 4 nodes cannot have values which are lesser than 2 and 3. Like for this node, it could not be lesser than 2. So it could be 4 and 5. This could be 6 and 7. Now if you want to optimize this, or if you want to push, say suppose 8 inside, you could gently push it here. But if you want to put 0 inside, well, this particular whole min heap will have to get inside heapification, or it will have to heapify itself to become optimum or a min heap again. Now this was more of how exactly min heap and max heap work and what exactly is a heap. Now getting back to Rust, if we want to differentiate between a stack and a heap, we'll say Only memory which has a fixed size, which is known at compile time, will be stored in stack. Growable data is stored in heap. Then we have LIFO based architecture here, or LIFO based approach here in order to get, or in order to push elements inside a stack. We have heapification happening, or heapify happening here actually. Then we have push and pull. We have already discussed. What exactly happens here is stack is a bit faster. If we are comparing, this guy here is a slower one. Now if I want to store anything, say suppose a string. Now in Rust, string literals could be stored anywhere. It could be stored on a stack. But if I'm generating, or if I'm initializing a string, something like this, string from ABC, this particular string will be more of let me write it here. Let me delete this part. Let me write it in a better way. If I say let s is equal to string from, now this string s is growable by nature. Now what we'll do is, what Rust will do is, it will save this string s inside our heap, and the heap will give a pointer. Say suppose let's name it p1, and this p1 will be stored inside a stack, so that if we want to check, or if we want to retrieve this value, we could directly go to stack and take it, and then ask heap that this is the pointer of the value which you have stored s, I want this value. So this is a brief introduction about how heap and stack interact. Heap, or whenever a growable data set is saved or has been run inside a Rust program, Rust will save it inside a heap, return a pointer. The pointer will be stored inside a stack, and whenever we want this data, we'll take it from the stack, we'll use the pointer to get the value from the heap. And this is the basic. In the next video, we'll discuss what are the laws of ownership and how exactly ownership works with heap and stack in play. I hope this was a little clear to you. Every detail will be there in the Notion doc. It will be attached in the description. I hope to see you in the next one. Bye.